Hi, I'm Charles Barrett, and I work for the University of Florida IFAS Extension. I work in Swanee Valley. I'm out here in Mariana today to talk a little bit about soil moisture sensors. And today I brought with me one type of sensor. It's a Syntec drill and drop. These sensors can be plugged into various different data loggers. This is a data logger here that happens to have a rain gauge on it as well. And there's various other types of sensors. There's big sensors, small sensors, tensiometers. Typically in sandy soils over in Swanee Valley where I do most of my work, tensiometers are a challenge. Out here where you have heavier clay soils, you can get away with using a cheaper tensiometer type sensor. But I think the take-home message with soil moisture sensors is that any type of soil moisture sensor is going to give you a better feeling of what's going on with your crop. My talk today is going to focus predominantly with capacitance type or TDR type sensors, this type of sensor, the probes, and I'm not going to talk about tensiometers. From using soil moisture sensors, we can see how much water the crop is using. So during the day, we'll see crop water uptake and our graph will go down. Our moisture levels in the soil will go down, and then at night that line will flatline, and I'll dive into some more of that detail. But from that we can tell how much water our crops are using, when they're using it, and if we're trying to match crop water uptake, we can do a really good job by using soil moisture sensors. So we see how much they're using, we can put that water back. Even in non-irrigated situations, we can monitor crop maturity and crop water uptake throughout the season. I've put soil moisture sensors out in hay fields, and it gives us a better idea of what's going on with the crop as far as water uptake, but also nutrient uptake. A lot of our sensors have soil salinity on them, and we can see kind of where our salts are accumulating at what depth, and we can use that to help us make fertilizer decisions. I'll caution you, the salinity data is more difficult to interpret, and it takes a trained eye maybe, and to look at it over a longer time scale than soil moisture, but it can be done and it can be super helpful. Soil moisture sensors are also a very good way of telling us when to start irrigating again after a large rainfall event. I always say that it's easy to irrigate in a drought because you need to irrigate, but after a rainfall event, how long do I wait before I kick that pivot back on? Soil moisture sensors can help you figure that out. You can watch water uptake over the course of some days and then figure out, okay, I'm starting to dry out in my upper portion of the soil and my roots are having to work harder and harder. Sometimes that's a good thing, but we don't want to stress a crop at a critical time, so that would be the time to kick on the irrigation. Soil moisture sensors can help us discern that. And so this is just one type of sensor. There's all different kinds. There's big ones and small ones, and my advice is if you learn how to read and understand that data, which is what I'll talk about next, then you can use any type of sensor and it'll help you with your crop. All right, good afternoon everybody. I wanted to give a quick talk today about irrigation scheduling using soil moisture sensors, and I guess I'll just jump right in it. This first picture of me standing in front of corn shows one type of soil moisture sensor. Most of the sensors that I'll focus on today are capacitance type or TDR type, and all that means is that the measurement that they're reading or giving in the data output or the display that you see is in volumetric water content, which when you're looking at soil, if you have an increase in water content, the line goes up, and when you have a decrease in moisture, the line goes down, which is in inverse to a tension-based sensor. So I won't be talking about tension-based sensors today. And so going into this PowerPoint, when I think of irrigation scheduling, I think
of this schedule on the left-hand side of the screen that shows um, basically crop water demand over time. And as you would imagine, as the days after planting increase, the amount of water demanded by the crop increases. And so you get this nice curve with most crops, or in a perennial crop based on the season. You'll see things wake up out of dormancy and they'll need more water in the spring and in the summer. And so I have this type of irrigation schedule in mind, and I usually use a schedule like this if I'm planning to irrigate a crop, and then I'll use my soil moisture sensors to fine tune that schedule. This schedule is based off of history, the evapotranspiration or the crop water use based on historical weather patterns. And so it's going to get you close. It's going to be in the ballpark, but it's not going to be perfect because every year is a little bit different. And so that's where the sensors can really fine tune how much water we need to apply. And so I think that's what I'll focus mostly on today is okay, we understand scheduling, we get that the crop as it gets bigger, it uses more water. How do I use these sensors to make any meaningful decisions? And so what you'll see a lot of times is something like this, where the sensors in that probe produce a line, one line per sensor. And so on the left-hand side of the screen, you can see where a sensor is, and kind of I have it lined up with the output of where the line for that sensor is. And so for the display that I'm showing, that sensor reports out this top 4-inch line at the black colored line at 4 inches, the red colored line at 8 inches, blue colored line at 12, this yellow or orange colored line at 16, and this green line at 20 inches. And so you can kind of visualize how that would be installed in the soil. And then you get this line, these lines here, and then you get the roots. And so the roots are growing down into the soil profile, and I can see where those roots are based on these lines, where these lines are making these stair-step looking patterns, and I'll describe that in more detail. But first, let's talk about whether or not these lines have any basis in reality, because that was my first question when I first started looking at soil moisture sensors. So I did this little test here that you see in front of you, where I put blue dye on the left-hand side of the screen. You can see this picture of ryegrass. I put blue dye on that rye, and then we irrigated it in. And basically what we did up here at the top, this top graph, more towards the center of the screen, I applied 3 inches of water there. I applied 1.5 inches on the graph in the middle, and I applied 3/4 of an inch, 7.5 of an inch, on this bottom graph. And then I watched how deep the blue dye moved. And the blue dye moves more or less like nitrogen or potassium. It moves in the soil profile. And so with bone dry soil, this soil, we were in the middle of a drought when I did this test. The line with 3 inches moved blue dye from the surface down 20 inches. Blue dye applied at the surface with 1.5 inches of irrigation applied moved down 16 inches. And then with 3/4 of an inch of irrigation, the blue dye moved down about 12 inches. So I was able to see that there is a direct relationship with movement of blue dye with the soil moisture sensors. These outputs picked up an increase in moisture down to this green line here, down just about to this orange line on the second graph, and really stopped up here on the red line, maybe a little bit on the blue line on the bottom graph. And that corresponds to where I see the blue dye move and the depth at which these sensors are placed, because the red line is at 12 inches. So I had a movement of blue dye down to 12 inches, and I had an increase in moisture down at 12 inches on the red line. This green line on this top graph is down at 36 inches. And that's kind of what we would expect with applying 3 inches of water. We would expect it to go down around 3 feet. If our soil can hold about 1 inch of water per foot, we apply 3 inches, it should go down about 3 feet. And so we see that. And so yes, the confirmation of do the lines represent reality is there. It does. So, okay, now that we know that the lines represent what actually is happening in reality, then what do they mean? And I think I started by discussing that an addition of moisture is an increase on the line, and a decrease on the line is a decrease in moisture. So, but what are the patterns telling us? So I guess what I can say is, if we look over here at this last peak, we can see that we had an increase in moisture. So maybe this was an irrigation event. To me, it looks like an irrigation event, a nice shallow one, because we irrigated at 4 inches and we had an increase in moisture down here at 8 inches, and then nothing really happening down here on this blue line down at 12 inches. And so, you know, I can tell how deep we applied moisture, or how deep that last rainfall event went, by looking at how deep my lines spiked. And so same thing over here on this first peak, we see the black line go up, we see the red line go up, and then we see the blue line go up just a smidgen. So the water probably, the wetting front of the soil moisture probably stopped somewhere between 8 inches and 12 inches. So if we call that 10 inches, you know, we can kind of guesstimate how deep the water went. But what I really like to focus on in a little bit more detail is what happens during the day and what happens at night. So anytime I see this day-night pattern, what I can show is that during the day, right around somewhere around 9 a.m., we'll start seeing root water uptake. And it starts off gradual because the sun is coming up, and then it gets more intense, and that line starts to dive down at a more steep slope. And then at night, as the sun starts to set, that slope gradually dissipates into no water leaving. And then we see that the same thing happen the next day. That same pattern repeats. And so this is exactly what we see when we have root water uptake. And this makes sense biologically with the plant. It takes up water during the day as it's transpiring. And then at night, not a whole lot's going on. There is some refilling of the plant, so that in the morning the plant is at full turgor pressure. It's fully filled up with water if you have good moisture to fill the plant back up. But that's really a small amount of water in comparison to how much water the crop uses during the day. And so that's why the difference in day and night is so clear on these graphs. And then with this soil moisture sensor output, we have two graphs. We have this top graph where we can see at what depth at each line what's happening. Then we can also see this sum line down here at the bottom. And there's a few vendors out here that have a soil moisture sensor that have this sum line down here at the bottom. And from the sum line, I can say, okay, all of these lines on this top graph, how much ever they went down during this day, this is my sum of water uptake by the plant for the day. So if these 2 days are equal, meaning they're about the same length because they're 2 days back to back, if the sun intensity was about the same, let's say there was no clouds in the sky both days, then our evapotranspiration, or our crop water use, should have been about the same, right? All the weather conditions were the same. If they're not the same, the water uptake is less on this second day. That could mean that we're starting to run out of water. So we'll want to watch this. And you see here on this next day, this color-coded graph down here on the bottom, we have blue is too wet, green is good, red we start to dip into a little bit of plant stress. That triggered that irrigation event. And so we want to use these graphs to make this type of decision. If I see that I'm using less water this second day when I should have used the same amount as this first day because my weather conditions were the same, intuitively we should be thinking, well, I took up less water because there was less water there for me to take up. And when there's less water in the soil to take up, the plant has to work harder to get that water out of the soil. And so it took up less. So this is how we'll start to use this information to make an irrigation decision. If I see this for, depending on the time of year, if I see this for 2 days in a row, I would want to irrigate. But maybe this is when I'm fruiting or something like that, and I don't want to stress the crop at all. Well, I can see that I took up some here and I took up a little bit less here. I'd go ahead and irrigate. It just depends on the time of the season. So there's certain times a year that we're really encouraging the plant to stress a little bit, to grow some roots or to do something. So we can use this information to help spur that in the plant. Another soil moisture sensor output looks a little bit different. That's what I've just pulled up here on the screen. I have two big arrows here on the top, A and B. The A is a rainfall event, and you can see how quickly, this was a very intense, very strong rainfall event, and you can see how quickly water moves through sand. So the water went from 4 inches to 8 inches to 12 inches to 16 inches very quickly. And this sensor has many more lines, but I turned those off to just keep it to the top 4 to be able to tell a little less confusing story. But so we can't see how deep this water went. I know from looking at all the rest of the lines that the water went down to 30 inches, even though I stopped it here at 16. I turned off those bottom lines. So that was a really strong rainfall event. And then what we have in between A and B is the course of 1, 2, 3 days of water uptake with the crop, and we can see our root stair step pattern here between A and B on the 4-inch sensor. I start to see a little bit of wiggle down here at 8 inches at that same amount of time, but this is what we say in Florida, is that we're never more than a few days away from a drought. It's because our soil doesn't hold a whole lot of water, especially not when the plant's young and we only have 4 inches of roots. That's not going to hold a whole lot of water. And so to be able to go this many days between an irrigation event and a rainfall event, this is pretty standard for Florida. And so it was actually 1, 2, 3, 4 days. So on the 5th day, we irrigated. It was a small irrigation event. We only irrigated down to where we just had started seeing roots down here at 8 inches. And we're trying to keep most of that water up here in 4 inches where the bulk of our roots are doing all the work. And we had another rainfall event here on this next series of spikes. But the main point of this graph that I'm trying to show is how quickly roots are going to grow. This is a corn crop, and so you see here at 8 inches, just in the matter of a few days. So this was around April 18th. We had roots, perceivable roots here at 8 inches on April 23rd, then down here at 12 inches, somewhere around April 26th, then down here at 16 inches around April 29th. So, that's like exponential root growth. From the 23rd to the 29th, we went from 8 inches to 16 inches with our corn roots. So roots are going to grow fast, and you're going to be able to see them taking up water by seeing these stair step patterns down here on the soil profile. And so that's what we want to do. That's how we want to use these soil moisture sensors. What I would take away from this is, if I was going to make an irrigation event on the 23rd or the 26th, something like that, I know where my roots are at 8 inches, at 12 inches. I can adjust my run time or adjust the amount of irrigation that I'm applying to a little bit more than I would have earlier on over here on April 18th, where I only had roots at 4 inches. now my root capacity has tripled by the time I'm at April 26th, and I can apply more irrigation water at one time, and that should last me a little bit longer than just trying to manage all my water at 4 inches. So I think that's a useful tool or a useful perspective with these soil moisture sensors. And then I'm just going to kind of throw you guys into the deep end here, and just know that a lot of times I too, when I look at these, I see just a bunch of wavy lines at first, and then I like to dive in. I can dive in and start to assess what I'm seeing. And the first thing I'll point out is it looks like here in these blue circles, I have 2 irrigation events a day, 2 long irrigation events because of how deep I see the water going. And so it's 2, 2, 2. Looks like here, this irrigation event, they started to turn it off and said, nope, I need a little bit more, and turned it back on. But then over here, we have 3 irrigation events a day. And this was when Bob Hockmuth and I started working with this farmer, and we convinced this farmer to switch from doing 2 irrigation events to 3 irrigation events. This is on watermelon. And so what we see down on our sum line is they called us here, this grower, and said, hey, I'm running out of water on these watermelons. This is the middle of the season. The watermelons are about the size of a softball, so the watermelon plants are taking up a lot of water at this time. And, at 3 o'clock in the afternoon, they're seeing drought. They're seeing wilting on their leaves. And the call came in saying that we're thinking about turning on the pivot. And Bob and I, both thought that was not going to be the best idea because, you start putting on a lot of water overhead and you start getting disease issues in watermelon. And, it's pretty early in the season still to be thinking like that. And so, we took a look at these graphs and we came up with another game plan. It's a little bit more work running around turning on valves, to irrigate 3 times a day versus 2 times a day. But what we were able to do is, as illustrated with this blue arrow, is to level things out. This reduces stress on the crop. And it actually supplies more irrigation water in the root zone when the crop is using it. And so what we saw as well, if we look up here on this top graph, is this green line here. It started to level out more. That green line is at the very bottom of this root zone. So the more level that line stays, the less up and down we're seeing on that line, the less water and nutrients we're moving down past that root zone. And so we were able to keep more water in the root zone by not over irrigating. And so these two events over here were 2 hours each. So for a total of 4 hours, and we were getting behind. As you can see with this red line here showing the trend there, we're getting behind. When we switched to 3 irrigation events of 1 hour each, we're applying 1 total less hour per day, so saving water and diesel, but also keeping more water in the root zone. And we're seeing that we're not stressing the crop. We're not getting behind, and we're not getting ahead. We're not leaching water down past the roots. And so, sometimes it's all we can do with these sensors to try to make a little bit of sense out of what's going on here. But here's an example of where, even if our farmers or our agents or whoever doesn't understand exactly what the sensor's telling them, somebody like me or somebody that knows more than me about soil moisture sensors can be a useful resource to say, hey, look, I have these sensors. I'm not 100% confident. Can you help me take a look at it? If you've got something like this, somebody like me can come in and take a look at this and hopefully make some sense out of it and help you decide, what's the most appropriate decision to make next. And, turning the valves on one more time and adding an irrigation event, the grower told us, that I thought that was a bad idea. I thought it was going to be a lot more work. Once I started doing it, though, it wasn't the end of the world. Yeah, I was running around like a chicken with my head cut off, turning on valves, but it saved my crop. And it happened to be that the year that this happened, the watermelon market stayed good, and she told us later on that season that was the best thing that she did was to listen to us, because if she'd have irrigated overhead, she would have lost that crop and and potentially missed out on a lot of profit. And so, I understand that, it's not always the time and place to be able to um, create a lot more extra work for yourself, going out there turning on more valves, or however you're irrigating. If it is labor intensive, it might not always make sense, but at least this tool can give you that advice. It can say, look, in a perfect world, this is what we would do, um, and here's the data to back it up. Understanding that the world's not perfect, and oftentimes we have to make decisions that make economic sense, not 100% sense, for growing a crop. And so I'll stop there. But we do have sensors all over the state of Florida. I have a couple of yellow dots out here in the Panhandle where I know that Libby and Ethan have started some work with some folks with soil moisture sensors. I want to make everybody know that I'm available for consultation on any of these things. If you feel like I can help, I'd love to be able to help out. Definitely recommend working with your county extension agent and getting a hold of me. If there's anything I can do to help, I would gladly do it. And I thank you for your time. And my email's down here at the bottom, cebarrett@ufl.edu. Just let me know. And I appreciate it. Thank you.